So my name is Joe Dunn, and I'm going to make some introductions with the rest of the team. But today, again, we are going to look at a brand new product that's available for Onshape from the Onshape App Store, and it's for doing CNC computer-aided manufacturing on your Onshape designs. And it's CAM in the cloud. It's really one of the first products, in fact, the first professional industrial strength CAM product that I've seen available as a product that works for Onshape. Now, I will let the team introduce themselves, but before we get started, just logistically, make sure you ask questions. We want to try to get through the presentation, relatively soon or fast, and we will show up as much of the product is as of interest to everybody. But this is not a training session. This is just to kind of give you an idea for what's available and what the product does. But ask questions. This is a place where you can get questions answered interactively, and we will at the end make sure to answer those questions. And if we can't, we'll follow up. This will be recorded so that you can watch it or send it to your coworkers if they need to see it as well. But the questions in the GoToMeeting are really key. They tend to be one of the better parts of doing the webinars, is being able to answer that. And this is my face. We're not doing our webcams today, but my name is Joe Dunn, like I said, and I am an Onshape employee, and my background is mechanical engineer coming from SolidWorks for many, many years. I was one of the original guys at SolidWorks, and now it's really exciting to be doing this at Onshape. And then we're going to be joined by Uday, Joe, and Don, and all three of them are with us. You guys want to just say hi?
Hello, everyone.
Hi there, this is Joe from MecSoft.
Hello, everyone. This is Uday from MecSoft.
Hey, guys. So I think what we'll do is I'm going to do, just in case there's quite a few of you that are joining us today, and chances are you may not have used Onshape yet. So it's always a good idea for us to cover just some very basics of Onshape. And I'm going to go through that very quickly because really the point here is to show VisualCAMc and talk a little bit about MecSoft as well. So guys, I'll let you guys introduce yourselves in a minute. Why don't I just cover the Onshape stuff real quick and then hand it over to you, Joe, okay? And so I think what we want to do is a little bit of Onshape just so you understand what it's all about. Then we'll talk about MecSoft and get to the demo right away. So assuming that you haven't used Onshape, or if you haven't checked in a long time, I always find this to be a very good thing to do, a good set point to just go back and realize what we've been going on. We've been a company for a few years, but the product itself, Onshape, is just really come on the market about a year and a half ago. So we're about 1.5 years old. And what we're doing is we are building I like to call it a brand new, it's a modern take. It's a modern version of what all the old mechanical CAD systems that exist today are doing. We're building a high-end, professional-grade mechanical design tool. We do parts assemblies, drawings. It is a platform, as you're going to see, where what we can see with VisualCAM is adding the manufacturing on top of the Onshape design, but it's a very common types of tasks that a mechanical engineer would do with Onshape. And we know that we're solving very, very tough problems. We're not making, this is a product where if you have a difficult, large assembly, difficult geometry, just anything that is not what you would expect to be able to do with let's just call it a mid-range product or a low-cost product in that respect, this is what you're going to use Onshape to be able to get the job done, right? And our focus is always about, I call it industrial strength, and that's really what we're looking at is what is the toughest engineer going to need to be able to use Onshape. What's new about it, across the board, there's all kinds of new things. The fact is that we don't have updates as far as you downloading and installing. There are no versions. Okay, when you use Onshape, it's always up to date, and the entire world gets one version of Onshape. When you use Onshape, you're just on the current version. So all this idea of worrying about whether your models regenerate, worrying about whether or not people have the right version, worrying about whether it's installed on the right computers, whether you have the right computer, all that stuff goes away. It's just not an issue anymore. We have a roadmap of what we're putting in the product, and this is just a glimpse of it. And I have, I think, 3 pages of this, which is not even complete because I can't keep track of it. But every 3 weeks or so, we push out updates to the product. So when you log in, you see that there's new functionality. And sheet metal was an example of that. We were at a trade show. Cody and I were at a trade show. By the way, we're joined by Cody Armstrong as well. He's just going to be the silent administrator for us on this. So just in case anybody knows Cody. But we were at a trade show, and that day when we showed up, we had sheet metal functionality. So, I mean, it's really, really great to be able to use a product where you're just not doing this administrative tasks like you do with a typical desktop app anymore. You shouldn't have to spend time doing that. The other thing is that it's, our goal when we started Onshape was going to run on all platforms, and that means really your local computer is not really the major requirement anymore. We run on Chromebooks. I have an Acer small, $200 Chromebook. Onshape works great on it. Or I could use tablets, or I can use Windows, or I can use Mac. The full product, everything runs anywhere. You have full access to all the product. And because it's not, one of the reasons for that is you don't have to download and install something. As soon as your application requires you to download and install, you're already compromising a lot of things, and you're basically going to be running on that local hardware and have all the pitfalls of that. So this was our goal, and we weren't even sure if we could do it, 3-4 years ago, and it was really, I think, groundbreaking when you use Onshape to realize that you are running on just about any different type of hardware that you can imagine. And we are a true cloud-based product, and that means that, it's running inside a browser. I kind of spoke to some of these things before. One of the things that I think is really interesting is two things. It's that the performance is awesome. I mean, you can be on your local hardware. It doesn't really make that much difference anymore. And you got to realize that the power that you have now, is the cloud. And, I know that word doesn't mean a lot, except for the fact that when you're doing something in Onshape, how many CPUs, how many computers are actually helping you do that task? We architected Onshape to scale with the cloud. So you have just an enormous amount of power at your fingertips, and it's the reason why this is the industrial strength product and it's the product of the future today, really, for Onshape, for engineers. It's also, the last thing I'll say is that it's extremely stable. One of the things that you just don't do in Onshape is you don't do that defensive save where you're saving your model because you're worried about losing data, right? I could name any product in the world. I'll say SolidWorks because that was my frame of reference. But if you use that product for a few days or for a few hours and you didn't hit save, the first thing you do is you start to worry that you're about to lose all your work, and you go hit save. And if you've gone for the whole day, which is common, and you hadn't hit save, you really get worried because sometimes save will crash the product. So that's just something that doesn't even happen in our product. The platform gives a very, very different experience of reliability. And there are no files with our product. It is a system where you log in, you share models, you have complete control over your data, you have complete control over who has your data, where they are, when they can have it. You can grant them access, and you can take away control. So this idea of downloading, zipping, attaching to an email, that's just not necessary with Onshape. And we have really excellent tools for working together as teams, for working together and working in a controlled way as teams. And this is my last slide, or almost last slide, as far as the product itself. But it is a platform where you're compatible with just about any other mechanical CAD format out there. If it's coming or going to a mechanical CAD product, the chances are Onshape will support the format. I think I have a slide with just, this is on our website of all the different formats. But suffice to say that everything, reading in or writing out, we are compatible. You can read in Onshape or SolidWorks models or Pro E models. We support STEP, IGES, Parasolid. The list is continual, and that list constantly updates. Because every 3 weeks with that roadmap where we're updating, that means we're also keeping up to date with the current versions of all those translators. So the translation tool is always up to date as well. Okay, I talked a little bit longer than I hoped to, but the real meat of today's presentation is for VisualCAM, and we're going to talk about the App Store and how applications can add, more than just mechanical design. You in this case, subtractive manufacturing with CAM, and we're going to show how VisualCAMc will add that functionality in the cloud. So I think, Joe, what I want to do is turn this over to you. So why don't you do some talking while I make you presenter?
All
Or is
right,
it
Joe.
Uday or Joe?
Make Uday
Yeah.
the presenter, so he's going to be
Correct.
driving. So,
Sorry about that. Okay,
Well,
Uday, you should be able to share your screen.
okay, while Joe's doing that, okay, I can see Uday's screen now. I'm Joe Anand, and President of MecSoft Corporation, welcoming you all to join the webinar. What we're going to be talking about is VisualCAMc, which is our cloud-based, fully cloud-based production level CAM system for Onshape. We have released this on a private beta, so it's not quite available on the App Store. So if you go to the App Store today and go to CAM, you will not see it. You'll have to be invited. And so you can go to our website and go to our VisualCAMc page and actually join the beta. Ask to be join the beta, and then we will let you in to have access to that product. So, but what we want to do today is we want to give you a very short overview of who we are. You might not know, many of you might not know anything about MecSoft, and then once that's done, then we're going to go into a small demonstration of the product. Uday is going to be running the demo, and and also we'll be showing the interoperability between Onshape and VisualCAMc. Okay, who are we? So we are MecSoft. We are a company that provides state-of-the-art CAM software solutions for manufacturing in a wide variety of industries. That's really what we do. I mean, that's our core competency. We've been doing CAM for a very long time, and we really know what CAM is all about. And we also pride ourselves in calling ourselves your CAM partner. So what we mean by that is, CAM is a very service-oriented industry. It's not like once you have the product, there's a lot of other things that go on in the back end. So you have to make sure your post-processor works correctly and you're interfacing with the machine tool. And then there's a lot of support issues that come up in terms of how do you machine a part, how do you orient this part, what is the optimum way of machining it. So we are, not only do we provide the software solution, but we also provide you with full service in terms of support and servicing the product for the entire life cycle of the product. So that's why we call ourselves your CAM partner. So if you get into partnership with us, we truly view that as a partnership. We work with you in making you successful. So if you want to go to the next slide. And a little bit more about our company. We are a California corporation. We started out in 1997, so we've been in business for almost 20 years now. And we have presence in all our major world markets, which means, in Europe we have a very strong presence in the Far East, in Japan, China, and Korea, as well as Oceania, which includes Australia and New Zealand. We have representation in all the major markets, manufacturing markets in the world. And our products are in 8 major languages. They've been translated in 8 major languages. We are talking our desktop products here. VisualCAMc is still in beta, and it hasn't been translated. It's only in English at this point. So Uday, if you want to go to the next slide. A little bit about our customers. Our customers are quite varied. Uday? We have thousands of customers in over 50 countries. So we've been in business for 20 years, and there's a lot of customers using our products. So our products are used in all over the world, in many different institutions, in commercial shops, in universities. Everywhere we go, you see our products. So we're quite proud of that. Small shops to Fortune 500 companies use our product. And as far as our customer profile, we are very loyal, passionate, and repeat customers. When I say repeat customers, it's really in terms of the AMS, the annual maintenance service renewals that we see. It's close to about 80% of our customers. So it's our customers know the value that you're getting with our products, and also the quality and the production level quality that they are getting. So a little bit about our target industries. The kind of industries that we target are production machining. This is basically prismatic parts, any kind of widgets you're manufacturing. That's one of our strong points. Woodworking would be our next. And this is actually quite varied woodworking. We have luthiers, people using our products in making musical instruments, furniture making, boat making, all kinds of ornamental woodworking. That's one of our strong areas, woodworking. And then mold making, that's another strong area as well. This is where you're doing complex sculpted surface machining type of machining for the plastic injection molding industry. We play a little bit in the die industry as well, but not quite too much. Mold making is probably our strongest market. And then automotive as well. Automotive, some of the automotive carburetors and things of that sort are automotive parts rather than the actual automotive dies. Jewelry and artistic machining is also one of the areas that we target. And then finally, we also have the prototyping industry, which is also a very strong industry for us. Even though a lot of that is going to rapid prototype, 3D printing now, but there's quite a few shops still using CNC machining for prototyping. We are also strong in the education market. We're quite strong there as well. As far as our desktop CAM products, we have our flagship product is called the VisualCAMc product. This is basically our standalone product that includes both CAD and CAM. VisualCAD is actually a free CAD product. It's a CAD product that is targeted at the shop floor user. It's not, by no means is competing with Onshape or SolidWorks or any of that parametric CAD system. This is really targeted at simple users, so people who are getting started, hobbyists, and people with limited needs in terms of CAD. Maybe they're coming from AutoCAD and they want to bring in a DXF file and they want to machine it, and they don't need a big CAD system, the expense or the maintenance of a big CAD system. Then we would offer them the VisualCAMc product. We also work with we also have a plugin called RhinoCam. That's basically our CAM product that's running inside of Rhino. You might have heard of Rhino, which is a NURBS modeler out of McNeil and Associates in Seattle, and we work very closely with them. We've been working with them for a long time, and that's a very strong product as well. We also have a product running inside SolidWorks, and it's called VisualCAM for SolidWorks. It's a gold certified, fully integrated product. That's again the same CAM functionality, the mill and turn modules are running inside of SolidWorks. And then finally we have the Alibre CAM product, which is something that we released recently that's running inside of the Alibre Design 3D modeler. So these are our desktop CAM products. And now our foray into the cloud-based market with our partnership with Onshape started a year ago when we released the Onshape Connector product called Visual Import for Onshape. So what this allows you to do, this is actually available on this is a free product that's available on the App Store. You can go to the CAM App Store today and then download this product and install it. What this does is it allows you to import, whether you want to go to the click, it allows you to import Onshape models to the VisualCAMc product. I mentioned VisualCAMc, our standalone CAM product. You'll be able to bring in Onshape's part models into this product and utilize VisualCAM to create the cutter paths for CNC. This is a free product that's available, so if you're a VisualCAM user, this is a great way of working with Onshape without any other additional products or anything else that needs to be added. And then finally, what the crux of today's presentation is the Onshape integrated product, VisualCAMc, which is basically our VisualCAM desktop technology now running fully on the cloud. And what this allows you to do, so that if you can click, it allows you to create 2.5 and 3-axis milling toolpaths for Onshape parts. It's fully cloud-based. It's running on the servers on the cloud, and it runs on any browser on any machine. So that's basically our foray into the cloud product with the Onshape integration. So you will be able to, we have the Parasolid kernel as well, so there's no translation involved in bringing in Onshape models into this product. So there's error-free loading of parts, and and we have the power of our desktop CAM solutions integrated into VisualCAMc. As I mentioned before, VisualCAMc is in beta right now. We are taking active signups for the beta at this point. So if you're interested, go to our website, and we actually, Uday can show you the actual web page that you can go in and log in and go to the form and sign up for the beta today. So with that, let me hand it over to Uday for a demonstration of the VisualCAMc product. Uday, want to take it over?
Thank you, Joe. Joe Dunn, would you like to go ahead and share me a part so we could go ahead and CAM
Yeah,
it
why
in
don't we,
VisualCAMc?
so what we want to do is, let me grab the screen real quick. We just want to kind of point out the point of Onshape and how Onshape works a little bit. And, interesting, I was just in Onshape collaborating with one of you in the in the chat, so we weren't even using GoToMeeting, we were using Onshape inside, chatting together. But I mentioned before that anyone in the world we can communicate and start using, and anyone in the world can start using Onshape immediately. And so in this case, what Uday has done is he might be the manufacturing engineer, I'm the design engineer, and we're working together. But I've just simply received a simple email, and all I have to do is click on that email, and it brings me right into the model, and it pulls it up, and I don't have to worry about what computer I'm on or where I am in the world. I'm collaborating with Uday through that link in the email, and that does work with anybody. You can share a model with anybody, anywhere. They click on it, and they'll be right in this model. I know Uday's there because I can see that if anybody's familiar with Google Docs, you would know that this is kind of similar to the way a Google Doc works, where you can be both working in the same document at the same time. And so I know that if I was to just watch Uday for a second, if I click on this is always hard to do with GoToMeeting in a single screen, but he's on his computer, I'm on mine, and I'm actually just doing a follow me to watch Uday work in the model and do some design, and we can add some chat to the window, and we can do any change I make, he'll see. There's a single source of truth where it's not copies, and we don't have to worry about someone checking in or checking out the model. It just transparently works. Now, really, I'm going to make Uday presenter and let him take this over. So let me do that, and you should be able to share your screen now, Uday, and you'll just see that he's seeing the same thing on his end. So we're going from my screen to his screen, and voila, same thing. And now it turns into me instead of him up on the top. And we could have 5, 10, 20 engineers all doing the same thing in this model if we want to.
Thank you, Joe. Hello, everyone. My name is Uday. I'm the Technical Support Manager at MecSoft, and today I'll be presenting you the VisualCAMc beta, which is the fully integrated cloud-based CAM for Onshape. So as Joe pointed out here, this is our foray into the cloud-based market. And as you can see here, I have a document in Onshape, and I also have a part model in here. So once you've subscribed to VisualCAMc by going into the App Store in Onshape, you can go into insert an element, go to add application, and you'll see VisualCAMc right in here, and you're going to pick VisualCAMc. And when you select VisualCAMc, a new VisualCAM tab is being inserted right next to your Part Studio in here, and it's loading your VisualCAM interface in Onshape, and you can just select the part that you'd like to program today. So we currently offer 2 and 3 axis machining solutions in VisualCAMc beta, and the VisualCAMc interface is loaded. Your part is accessible in the viewport here, and you can see all of the CAM interface appears over right across the top. Our workflow is going from left to right as we work through each of these setups in here, and you'll also notice that the CAM interface, the machining browser, there's 2 tabs: the machining job, which basically displays all of the CAM programming that you're going to be doing here, and also you have the tools tab where we can define different types of tools. So the part, what I have here is a prismatic part, which means there aren't any drafts or sculpted bottoms or tapers. So parts like these, we could program them using 2 or 2.5 axis machining operation. The typical workflow in here is the first step is to establish your machine tool coordinate system. So in this particular step, you are establishing your X, Y, Z axis orientation of the part that's going to be milled on the machine tool in here. By default, Your coordinate system orientation is in the same orientation as the world coordinate system as you have it in Onshape, and as you can see here, the z-axis is currently normal to this particular face. If you need to mill the part or machine the part from a different orientation, let's say consider the bottom of this part in here, you could use these controls to rotate your coordinate system as needed, so the bottom of the part is now, the z-axis is normal to the bottom face of the part. So you can use all of these controls in here to go back and reorient the parts. I'm going to go back and set it to the world z-axis, and I'll pick save. And this information is updated, and it's automatically displayed under the machining job. So the machine tool type is defined as 3-axis. In our next step, we're going to select the post processor. This would be the machine tool that you're going to be outputting the G-code for. VisualCAMc by default includes post for over 300 plus different machine tools controllers out there, so which covers a wide range of CNC machines that are out there. As you can see, there's a vast list of post processors in here, and you can select the post processor either by the name of the controller or the name of the machine tool from the list of posts in here. Now I'm going to choose FANUC as my controller, and I'll pick save. The post processor information is now updated. In the next step, we're going to define our stock material. This is going to be the workpiece that you're going to be using to be machining this part out. And as you can tell, the stock dimensions are automatically established based off the extents of the part that you've designed. You could always extend the stock in here. So I'm going to make the stock larger in X and Y, offset it in X and Y by 100 thousandths, and I'll offset it by 50 thousandths in the Z-axis, and you can see that the stock is automatically updated on the graphics screen. I'm going to pick save. So you can see that each of the information that you programmed is being updated in the machining browser. In the next step, we're going to establish the work 0, which is also known as the part coordinate system origin, or the program 0. And I'm going to choose set to stock. We'll pick the 0 face to be the top face. I'll pick the highest Z. And for the 0 position, I'm going to pick the southwest, which is over here at the lower left corner. And this establishes your XYZ origin, which means all your machining coordinates at the toolpaths are going to be interpreted based off this origin, and your XYZ 0 is established right in here. We'll pick save. And this information is also updated under the setup tree. In the next step, we're going to program different types of machining operations in here. So we have 2.5-axis operations, we have 3-axis operations, and also we have whole machining operations that are currently offered in our VisualCAMc beta. Now, as I pointed out earlier, parts like these, which are prismatic, where there aren't any drafts or sculpted bottoms, you could program them using 2 or 2.5-axis operations. The reason it's called 2 or 2.5-axis is as your tool moves in X and Y, it remains at a constant depth. So the first step I'm going to do is start with a facing operation in here to face it down to the thickness of the part. And this displays the machining operation dialog, which has all the interface in here. We're going to step through each of these tabs. The first tab is the selection of the tool. You can define your tool either by clicking select tool under an operation, or you could go directly into the tools tab, and you could also define tools. Now, VisualCAMc offers you tools of type of ball and mills, flattened mills, corner radius. You can define taper tools, chamfer, engraving tools. You have face mill cutters, dovetail, fillet mill tools. We have drill, and also center drill tools. You can define tools of different tool types. Now, for the facing operation, I'm going to define a face mill in here, where I can establish the properties for the tool. I'm going to enter in the shoulder length, the flute length. So as you key in the information, you're defining your tool definition for the facing operation. You can also establish the tool numbers, your material for the tool, your coolant type, and then you pick save to save this information. So as I go back to the machining job, you will notice that the tool that we created is now displayed under tools. We have a face mill, and then the properties of the tool is displayed in the tooltip window right there. In the next step, you would want to establish your feeds and speeds. This would be you can establish your spindle RPM, your cut feed rates, your engage and retract feed rates. Next tab allows you to establish your clearance. This is the safety plane for your transfer and non-cutting motions, and when this tab is active, you can actually visualize the clearance plane right on top of the model. I'm going to leave it as automatic, and then in the next tab, you can set the cutting parameters for the facing operation. You can establish your tolerance, your stock allowance, a location of geometry for cutting. You can specify your cut types, like your cut patterns, your cut direction, your total cut depth. You can also enter in your depth per cut, your step distances, and you can also control the entry and exit parameters right in here for the facing operation. So you can see there's a lot of control that's available to you. And I'm going to pick the boundary in here. So I just did a right click to select the entire chain, and it automatically selects a chain of face edge at that particular face. In selecting generate toolpath, compute your toolpath, you can see the task process manager shows up, and there's the toolpath generated. You can toggle the display of the visibility of the toolpath on and off, so you have all the viewing controls. And then you would want to run a verification for it. So right click and then select simulate, allows you to run a verification. And there's the facing operation being programmed with the face mill. Now at any point of time during the toolpath animation, you could select pause and then exit from the simulation mode. You could also generate a cut model in here by selecting create cut model, which gives you the result of the cut material simulation. And everything is being computed on the cloud, so there is scalability depending on the complexity of the geometry that you're working on. And you can also toggle the display of the part model on or off. Okay, so we just got through a facing operation in here. The operation is programmed and it's listed under the machining job. So if you would like to make a change or modification, you can always double click on it to make the edits and then pick generate to generate the toolpath. In the next step, I would like to go ahead and pocket this feature in here. So I'm going to go into 2-axis machining and we'll pick pocketing. And in this particular step, I'm going to pick a tool and I'm going to use an end mill. So I'm going to pick a flat mill. We'll specify the properties for the tool in here. We'll establish the shoulder length, the flute length. We'll pick save. So I'm going to use a 1/2 inch end mill. And the process would be similar to establish your feeds and speeds, clearance, and then we'll go directly into the cutting parameters. Now if you like the default parameters that are in there, you can just skip through those tabs and go directly into cutting parameters. And you can specify the type of parameters. You have your tolerances. You can set the stock allowance in here. Choose your cutting geometry. You have different types of cut patterns. You can do offset cut pattern, linear or high speed, which is like an adaptive cut pattern. Specify start points. You can specify the step distances. And I'm just going to select the chain of these edges in here by just doing a right click on this edge. It picks up an entire chain. So your selection process is a lot easier for the pocket feature. Specify the step distance. I would now specify the total depth. And if I would like to cut it in multiple steps, I'm going to specify a depth per cut in here and then pick generate. We'll compute the toolpath. So the pocketing toolpath has been generated. You can rotate the model to view it. You can do a pan, zoom. You have all of these controls built into it. Now, if I would like to make a change, I'm just going to double click on it to edit the operation in here. I'm going to modify the entry to use a path ramp as opposed to using just a linear motion. I'll specify a height and an angle and then pick generate. You will notice that the toolpath with the changes have been updated, and you can notice that the path ramp motion for the entry right in here. Now once you have the toolpath computed, you can run a verification, right click and then select simulate. Will allow you to run a verification in here. And you could always select pause and then exit to end the simulation mode. Now finally, I want to drill the holes and then profile these slots in here. So I'm going to go ahead and select 2-axis. So once we're through with the pocket operation in here, we'll do a 2-axis and a profiling. So you can see that the feature we selected is automatically pre-selected from the previous operation. And I'll still continue using the same end mill. And I'm also going to add a few additional features in here where I'm going to pick these chain of these edges in here as well for the profile operation. So just simple right click on each of these edges will automatically pick those geometries in addition to the one that we selected. And I'm going to specify my cutting direction. We'll put in the total cut depth as 1/2 inch. We'll do it in 2 passes and choose the side to be on the inside and then pick generate. So it's going to do a cleanup around this pocket, which we left a few thousand stock in here, and then it's also going to go ahead and machine these slots in here as well on a profile operation. Now finally, I'm going to go ahead and drill these holes in here. We'll select hole machining and drilling to drill the holes. And now for drilling, I'm going to create a 3/4 inch drill tool, a drill bit. We'll specify the tool properties. We'll specify a tool length of 3 inches. I'm going to save this tool right in here. And we'll establish the feed speeds, clearance, and the parameters, very similar to what we did on the previous step. And now I'm going to just select these 4 holes for the drilling operation in here. I have those 4 holes selected. My drill depth is set to 1/2 inch. I'm going to select add the tip to the drill depth. So it basically ensures that it's going to be a through hole to compensate for the tip of the tool to go past it to make it a through hole. So there's our drilling operation. Let's go ahead and run a verification in here by selecting simulate. And there's the simulation of your drill operation. Now once we have all these operations programmed in here, they're all part of the same Onshape document. You would want to go ahead and then output a G-code to your machine tool. So select the setup to output all of the operations, right click on it and choose post process. In this particular step, it's automatically going to output the code, download it, and preview it in a text editor. And there's your posted output file for each of the operations, and you can see those tool numbers being called out for each and every operation that's being programmed in here. Now this particular file is ready to be transferred out to your CNC machine controller. You could be DNCing it, or you could be transferring across your network out to the CNC machine. So this gives you a quick workflow of how you could program 2-axis operations. The next thing I'm going to demo here is how to use VisualCAMc for programming 3-axis operations. So I have a cavity mold in here. It's a 4-cavity tray, as you can see it. And to program parts like these, you would typically have to use a 3-axis operation where you're moving all the 3 linear axes X, Y, and Z simultaneously, as the part has radiuses, sculpted features, sculpted bottoms on it. So the typical workflow in here is once you have the part designed and have the VisualCAMc tab loaded, you'd want to go ahead and establish your machine tool coordinate system. So you select machine, establish your coordinate system for machining. So the Z-axis is normal to this particular face. I'm going to set it to Z-axis and then accept it. The next step, select the post processor in here. Very similar to how we established the post processor on the previous example. So I'm going to go ahead and select the post processor from the list. I'll pick Fedal as the post processor. I'm going to hit save. And then we'll go ahead and define our stock, which is going to be the workpiece we're going to be starting out with. So as you can tell, the stock extents are automatically established based off the geometry in here. If you need to specify offsets, these can be set right in here. And we'll pick save to save this information. Now once we have the stock established, we'll go ahead and establish the work 0. This is your program 0 or your XYZ origin for machining this part. We're going to choose the 0 to be set to the stock material. We'll pick the 0 face to be the highest Z, which is the top face. And we'll pick a southwest corner, which is the lower left corner, to establish our XYZ origin. So by establishing the work 0, all your toolpath coordinates are going to be interpreted based off this origin in here. So in this particular part, when we program the toolpaths, you would end up with the positive XY coordinates, and since the Z is set to the top of the workpiece, your cutting motions in the Z would end up being in a negative Z. Now to program a part like this, typically the workflow is to rough it out, to hog as much as material out inside the cavity using a roughing process. So we're going to use a technique called Z-level roughing, or also known as horizontal roughing in our desktop products. So I'm going to choose Z-level roughing. And once I select the Z-level roughing operation, you'll notice that the operation parameters are accessible right from the machining browser. We'll select our tool in here. So I'm going to pick a flat mill, which is typically what's used for roughing process. We will then establish the feeds and speeds for roughing, where you can establish your spindle RPM, your cut feed rate, your engage and retract feed rates. And in the next step, you would want to establish your clearance, very similar to how we did in the 2-axis example. And then we'll go ahead and establish the parameters for cutting in here, where you can establish your tolerance, your stock allowance. You have your cut patterns in here. We can choose offset, linear, or you can even choose the high speed, which is the adaptive cut pattern. You can specify your step over distances, and you can also set the step down distances in here. And once you have these parameters established, you can establish your entry and exit parameters as needed, and then pick generate, and the toolpath is being computed. And all this information that you're seeing is being processed on the cloud through the servers. So there is scalability depending on the complexity of the part that you're working with. And everything is handled automatically in the backend. And the toolpath is generated, and you can see the toolpath being previewed on top of the part geometry. So once you have the roughing operation program, you can right-click and choose Simulate to run a verification. And there's your toolpath animation in here. I'm going to pause it, exit the simulation mode, and go ahead and run a cut model. So right-click and cut model creates your result of the cut material simulation. So if you do have any questions, you're welcome to post those questions in the questions panel, and we'll try to do our best to answer them for you. So it's receiving the cut model data, and there is the cut model after the roughing process. As you can see, the cavities have been roughed out. Now once we're through with the roughing process, in the next step we're going to program a pre-finishing or a finishing operation, and this is typically done using one of these finishing methods. And I'm going to start out with a method called parallel finishing. And typically for a finishing operation you would want to use a radius tool like a ball and mill. So I'm going to pick a ball mill. We'll establish the feeds and speeds and clearance, and then we would go into the cutting parameters where you can establish the cut pattern, the step overs, the direction of cut. And in this particular case I would like to contain the tool path inside the cavity, so I'm just going to right click over the edge in here, and as you can see here it automatically picks a chain, automatically selects a containment boundary to contain this tool path. We'll then establish the direction of cut, so I'm going to set angle of cut as 45, the step over distance, and we'll choose generate. So the tool path is being computed, and once the tool path is generated, it'll automatically preview on top of the part model. And it's receiving the tool path data, and all the computation, as I said, is done on the clouds and the backend servers. And there's the generated tool path. I just toggle the display of the tool path, and there's the finishing pass. If you'd like to make a change, you could always double click to edit the operation. I could go back and tighten up the step distance in here and go back and generate the tool path. So a simple click to edit the operation, to update the parameters and regenerate. And the tool path is being regenerated. Now once we are through with the parallel finishing operation, you could go back and add another finishing operation to generate a final finish pass. And this could be like a finishing in levels, something similar to that. We call it Z-level finishing. And as you can see, the toolpath data is being received for the parallel finishing operation with a tighter step over that we just programmed. And there it is. You would like to go ahead and run a verification in here, right click and simulate. Runs a verification of the finishing operation. So I'm going to pause the simulation and exit from the simulation mode. And we'll go back and program a final finishing operation in here. This would be a finishing in levels. You're going to use 3 axes, Z-level finishing. And I'm going to still use the same boundary in here, the containment boundary. You can see that the containment boundary was automatically transferred over from the previous operation. We'll use the same ball and mill tool that we used. And then for the cutting parameters, I'm just going to set my step down distance to be 1/8 of an inch and generate the toolpath. So this is going to create a Z-level finishing operation. So the finishing is done in steps or levels. And this would result in a very nice finish for steep areas like the side walls of the part. So once you have all of these operations programmed, you could make a change. If you want to edit the operation, you can double click on an operation in the tree to edit the operation. If you want to delete an operation, you can just select it right click and then choose delete to modify or delete an operation. So it's very intuitive. You can make changes, graphically edit the operations, and then finally, once you're happy with the workflow and the operations that you program, you could go ahead and post-process these out to the machine tool.
Uday, do you want to start fielding some questions given our time constraints here?
Sure.
I mean, yeah, they're stacking up, so I want to make sure we don't cut ourselves off before the end.
Sure. So the toolpath was completed in here, and then the final step is to post-process it out, and then I'll be more than happy to take the questions and answer them out. I'm ready, Joe, whenever you are.
Yeah, I'm not sure if this is for who wants to answer this, but I mean, I think let's talk about the availability just in general, because a bunch of questions came up about how to get access and when will this be available.
Yeah, let me take that question, Joe. I had actually posted the links on the chat window, so if anybody is interested in signing up for the beta, look in your chat window and you'll see a couple of links. The first link is actually to the forum where you can actually sign up for the beta, and the other one is actually to this web page that Uday is just showing you. That gives you more information on the VisualCAMc product itself in terms of what is the feature list, and there's if you click on that learn more, Uday, if you can go back to the page, yeah, if you click on the learn more tab, you'll see a bunch of videos here that'll get you started on how to use the product, and there's a quite extensive online help as well in the product. So please look in your chat window for the links, and then once you select the sign up form, we will add you to the VisualCAMc beta team. So if you go back to that sign up form, so this is the sign up form that'll come up when you click on the first link that I sent you. And once you submit this form, we will add you to the VisualCAMc beta team, and you will get an email from Onshape saying that you've been added to the team. And once that happens, you will have access to the VisualCAMc product in the App Store. So you can go to the CAM App Store and look for this VisualCAMc product at that point, and then add it to your add it as a tab to your Onshape document. There was a question on post-processors. How many post-processors do you have? So if you can just show the drop-down on the posts.
To the best of my knowledge, we have over 300 posts. So all the posts that we have on our desktop product are all available in the VisualCAMc as well. So you could select the post from the list. So there are a little over about 325 to 330 posts.
Okay.
Is there if someone has a specific post that they need, is there any way they can get one created, or do we just have to wait for the customization?
Typically what we do is we do the customization, and there's some simple customization users can do. The real question here is how do we, once they customize it, where do they save it, and how do they access it? They might want to share it with their teams, their company people, and all of that. Those are the things that we're working out right now, and that'll be definitely be part of the first release. So.
Right. Hey, it might be, I saw a lot of tool questions come up. Maybe pull up the tool library and talk a little bit about that. Can't hurt.
So currently in the beta, you'd be able to define tools of different tool types. So you can have one or more of each tool type defined in here. Ball mill, flat mills, you have corner radius tools for engraving, chamfer, taper, face mills, dovetail, fillet mills. You also have lollipop tools, and also drill and center drill tool types. So each of these tool types can be defined on the parts that you're currently programming, and then you could use them on the operations that you're programming in here.
Cool. There were a couple questions about, they may be related, but collision detection, solid modeling verification, or simulation I should say, and I don't know if those are the same or different, but probably best for you to talk about collision detection.
Yeah, let me take that one. What they showed today in the product is basically a rudimentary form of solid model, stock creation, or if you will. So the actual machine model is being created as a solid model. We are working with a third party library, which is almost all CAM systems use for the actual creation of the solid modeling cut material model rather, and we will be integrating that shortly, and that would come up, that functionality will allow us to do collision detections with tool holders and things of that nature.
And what about stock? I haven't tried it yet, but can we bring in a solid as stock at this point, or is it still, I know there's an option for that.
Uday, you want to take that?
Sure. Currently, we define the stock as a part bounding box stock, which is basically a rectangular block. So in our desktop products, we have different stock types. So I'm sure we will probably be seeing more options as we go along in the VisualCAMc as we transition into a release version. So we'll probably have more options. And so at this point of time in the beta, we have a box stock that you can define.
We didn't touch on cost, and I see that poking up a few times as well. So Joe, you might want to talk about cost of the product as well and what the plans are.
Okay. As far as the cost for the product, we still don't know, completely. We don't have a good idea of the costs. That's one of the reasons we released this beta. That this beta period, which we're anticipating a 3-month beta period, would give us enough information on the server costs, what are the back-end costs, how many toolpaths are you running, and how big is Amazon or Azure going to send us, and Microsoft's going to send us in terms of bills. So we need to figure all of that out. But having said that, what we know in terms of cost is it will be a subscription-based product. That we know for sure. And then number 2, it'll be competitive to our desktop products. So the pricing will be competitive to our desktop products. So those are the 2 things we know for sure. But the actual business model, we're still working out at this point.
Well, you might want to just tell them what the desktop model is. I know they can look it up. But.
Yeah, the desktop model pricing, which is a perpetual license pricing, is $1,500 as a perpetual license. So we would come in around that, maybe a 2-year, 3-year subscription around that price range. So that's what we're looking at this point.
So I see a lot of questions about, there's a lot of questions, guys, so we're not going to get to everything. But I think a lot of them are, can you do 4-axis? Can you do 5-axis? Do you do turning? What I see is like a lot of, future modules and stuff. So maybe talking about the roadmap a little bit as much as you can might be a good idea. Like where it is now, where you expect it to be.
Yeah. So at this point, we have a roadmap, and that roadmap obviously is subject to change depending on input from our customers, our beta testers, and obviously once we release it, depending on what our customers want, it's subject to change. But at this point, the roadmap is in a 3-month time period, around the December timeframe. We want to release the first commercial version of VisualCAMc, and that would be a milling only product, which would include all of our standard configuration functionality, which will, if you look at the functions that are in VisualCAMc today, you'll see a little bit more. If you go to 2-axis there, Uday, and right now you see 4 methods. We will probably see an additional 6 or 7 methods here that will include chamfering, slot machining, V-carving, and things of that nature. And then in 3-axis, we're not going to be adding too much more. I believe that'll be the same level as the standard. And in the holes, hole making, we'll be adding tapping, boring, reverse boring, and as well as thread milling in the hole making. So that's the feature list that we have planned. And then there's other things in the back end that go on as well. One of the things we talked about was the simulation libraries being integrated, customization of post processors, customization of tool libraries, all of that will be included in the December timeframe. And then turning is in the plans, turning and then 4-axis and 5-axis after that, depending on, I mean, these are, again, we're looking quite a bit into the future. Those are subject to change. So I hope that answers the question or gives you a good idea of where our heads are at.
Yeah, I mean, this is like Onshape, guys. This will be a continuous improvement, and they're going to be able to distribute this because this is just like Onshape, a true cloud app. So you can expect to see, just a constant level of improvement as well. So it's really exciting in that respect. And it runs, think of it running CAM on, just about any kind of hardware as well. So just in case it's not clear, if you go to another computer, log in, not only do you have Onshape, but VisualCAM is also available to you right there. I think that we're about out of time, so I'm not going to ask. I think we've covered all the major questions. We can keep the Q&A open a little bit longer and type some more answers in just in case we didn't get to everything. Uday, you're showing one more, the YouTube channel, I think, right?
Yeah, what I was showing was how our beta users can access to the extensive help system that we put together, and also access the product videos. So you could just click on the pull down right next to the help, and then selecting help automatically launches a help system, and you can do search, and very similar to how Onshape's help is. So you can see that it's all on the cloud, so you can basically access all of the help resources and how to access the product right in here. And to learn on how to use the different operations and learn more about it, you can always go to help and click on videos, and it takes directly into our YouTube channel, and this playlist keeps getting updated with additional videos. So this is a good place to start. Even right in here you can find out how you can sign up for VisualCAMc for Onshape. So there are several videos, and our documentation team has done a great job in putting all of these together. And you can send a feedback to us as well by going into help and feedback and sending your comments as well.
Excellent. I think, guys, that's it. I'm not sure if we should wrap this thing up. Thank you very much. Like I said, we're going to keep the chat window open, but come and join and get access to the product and get some feedback and start cutting some parts. I've already cut a bunch of parts myself, so it's been fun.
Thank you all for joining, and like Joe said, we'll be listening to your questions. We'll be answering them here in the next 10 or 15 minutes here. Thanks again.